Okay, so quiz 19. Number 1, a radical cannot be used in it gives you several options. The answer is denominator. So, cannot have a radical in denominator. That's why we have to multiply both the numerator and denominator by the radical to get it out of there. Okay, number 2, the form of an expression may be changed by multiplying it by another expression equal to what? So, like I said, this whole section has to do with radicals, but what it's referring to is when we multiply either a side of an equation, or really in this case, the initial equation given to us, we can multiply it by something equal 1 to change the numbers, but it's not going to change the value. And let me show that and kind of work it out so it makes more sense, because it's very, I guess, mathematical and can be confusing, but it actually does work out on paper. So, just like 3 over 3 is equal to 1, 1 over 1 is equal to 1, we could say the square root of 5 over the square root of 5 is equal to 1, because those would cancel out and it's just left with 1. Square root of 2 over square root of 2 is equal to 1. So let's take a problem and just kind of play around with it. We can use our calculators too, just to prove this point. So let's say you have 2 over the square root of 5. So like we said, a radical cannot be the denominator, so to get it out, you have to multiply the numerator and the denominator by the same number. So when you're multiplying by the same number, you're multiplying by 1. That's 1. But just to show you that originally what we start with and what we get are not different, let's actually work it out. So 2 times the square root of 5 is still 2 times the square root of 5. Those cannot be mixed together. Square root of 5 times the square root of 5 is 5, and the reason is because it equals the square root of 25, which is a perfect square, which is 5. Okay, so this cannot be simplified further. That's as reduced as that square can be, and then these numbers are simplified as well. So this is our final answer. This is what we started with. This equals 1. Now, this does not look anything like this, but if you get your calculator and you say 2 divided by the square root of 5, this comes out to be 0.8944. Then if you take 2 times the square root of 5, and then you divide that by 5, it comes out to 0.8944. So even though these look very different, this shows that we multiplied it by 1, because the square root of 5 over square root of 5 is equal to 1. So you can multiply anything by 1, and you can change the numbers around, but you're not going to actually change the value around. Okay, number 3, when adding 2 fractions, we must first find A, the common denominator. Okay, number 4. So we're given 5 over the square root of 3. So we cannot have a radical in the denominator. So we're going to multiply the numerator and the denominator by the same thing. And then this gives us 5 times the square root of 3 all over square root of 9, because the square root of 3 times the square root of 3 is square root of 9. And the square root of 9 simplifies to 3 because it's a perfect square. Then we're left with 5 times the square root of 3 over 3. The square root of 3, once we've multiplied it out and gotten the radical out of the denominator, we want to look and see, is there anything else that we can reduce? First, reduce what's in the square root. Because if you can get a perfect square out of it, you're going to have more to reduce later with your coefficients and your actual integers. If you go ahead and reduce this, and then you do your squares, you're going to be taking more numbers out, so you might have to reduce again. So it's multiple steps, or doing the same step twice, I should say. So this is not a perfect square, there are no perfect squares that can come from it, it's good. And 5 and 3 cannot be reduced any further. So this is the correct answer, which is A. Okay, number 5. So 8 times the square root of 2 over the square root of 4. Well, first of all, the square root of 4 is a perfect square. So we can multiply each numerator, denominator, each part of the fraction by the square root of 4, but we really don't have to because we can reduce the square root of 4 automatically. So the square root of 4 is 2. So that would be 8 times the square root of 2 over 2. So we don't have any radicals in our denominator, which is the goal to get it out, whether it's we can simplify it here or we have to multiply it out. We want to look at our square root. That's as simplified as low as it can go. There's no perfect squares there. 8 and 2, can those be simplified further? Yes, they can both be simplified by 2. So 2 goes into 2 one time, 2 goes into 8 4 times. So you're left with 4 times the square root of 2. Technically that's all over 1, so that's still equal to 4 times the square root of 2. So the final answer would be D. Okay, number 6. Four times the square root of 3 over the square root of 8. Okay, so there are a couple ways that we can work this out. If you're used to multiplying by the radical that's in the denominator, then we can. We're trying some larger numbers to reduce later, but it's not a big deal. Or you can try to multiply it by a radical that'll give you a perfect square that's a little bit smaller. So meaning we could say times the square root of 2 times the square root of 2, and that would give us a square root of 16, which is a perfect square. But sometimes that's not our initial thing, so I'll do it the other way just to show, since we're more likely, since we get in that habit. So let's just go multiply it by the square root of 8, since that's what's in the denominator. So if we do that, 4 is our coefficient. Square root of 3 times square root of 8 is square root of 24. Square root of 8 times square root of 8, those of course cancel out and we're left with 8. Now we might be tempted to go and reduce these because it seems like a very obvious relationship, but go ahead and reduce your square root, what's in the radical symbol first. So square root of 24, what perfect squares are there? And if you need to remember, 4, 9, 16, 25. That's about as big as it's going to get here. So 16 does not go into 24 evenly, 9 doesn't go into 24 evenly, but 4 does. And it goes into it 6 times. So we're going to write that out. We're going to keep our coefficient in front, and the square root of 24 would be equal to the square root of 4 times the square root of 6. Square root of 4 times square root of 6 equals square root of 24. And this is all over 8. So the square root of 4 we said is a perfect square, which is 2. So we have 4 times 2 times the square root of 6 all over 8. I want to erase this top portion just so I don't go too low. So then we are left with 8 times the square root of 6 all over 8. Now square root of 6 is simplified as far as it'll go. There's no perfect squares in it. And 8s will cancel out. So we're left with the square root of 6. So that answer is B. Okay, number 7. Five times the square root of 5 all over the square root of 5. Okay. So look for obvious things. We can multiply each one by the square root of 5, but if we look, the square root of 5 over the square root of 5, those cancel out automatically, so it leaves us with 5. So we're done right there. The answer's 5, which is B. But let's say that we were in the mood of getting radicals out of the denominator. And the reason, by the way, that these can cancel out, It's because it's not being added together. They're being multiplied so they can simplify, just like you can simplify your coefficients. But let's say you didn't see that and you went ahead and multiplied each one by 5, which we can do. Or the square root of 5, I should say. So square root of 5 times square root of 5 is 5. 5, square root of 5 times square root of 5, we just said is 5. Which is really square root of 25. So which is 5. So 5 times 5 all over 5. So we're left with 25 over 5, which is 5. So a lot more math and working it out fully compared to if you cancel the beginning. But you get the same answer. So it doesn't change the answer at all. Okay, number 8. Three times the square root of 7 all over the square root of 10. Okay, so now that we can simplify automatically, so let's go ahead and multiply the numerator by square root of 10, the denominator by square root of 10. So we have 3. Remember, you can only multiply radicals times radicals, so square root of 7 times square root of 10 is square root of 70. And then square root of 10 times square root of 10 is 10. So we have 3 square root of 70 all over 10. Square root of 70, 25 will not go into evenly. We can check each of these, but they do not go to it evenly if you divide them on your calculator. So that's as reduced as it can be. And then 3 and 10, nothing goes into both of those numbers evenly. So you're actually done with this problem. So the answer to 8 is A. Okay, number 9. So 4 square root of 15 times 6 square root of 6. Okay, so let's go ahead and multiply by the square root of 6. Get the radical out of the denominator. So we have 4 times 4 times the square root of 90. Now in here, we cannot forget our coefficients. So that's a little different than our other problems we've had. So we still have our 6, but we have to multiply it by something else. We have the square root of 6 times square root of 6, which is square root of 36, which simplifies to 6. So we have another 6 there. So when we write that out, we have 4 square root of 90 all over 36. Okay, square root of 90. Can that be reduced any further? It can. So 25 and 16 will not go into it, but